Good evening, ladies and gentlemen, and welcome to the next video, Rate of Change. Today we're going to define and calculate the rate of change from several different representations. These representations being tables, graph, and word problems. Okay, so the essential question, the things that you really need to take away from this are, what does rate of change mean? What does it mean when you have a rate of change? And how do we find it? Okay, what are we looking for? How do we calculate those things? Okay, so there's your essential questions, and we will come back to these and answer these at the end of the video. All right, so let's dig right in. In order to understand this, we really need to talk about the definition of rate of change first. So that's what we're going to do. Rate of change is, the specific definition is the ratio between a change in one variable, y, relative to the a corresponding change in the other variable, x. Okay, so it's a ratio for a change in y for every x, how x changes. Okay, and so how we present that is really, you can kind of drill it down to a simple form, and that is change in y over change in x. Okay, and usually how you'll see it is you'll see that as equivalent expression to this, delta y over delta x. Okay, this is just a Greek symbol. That little triangle, it's called a delta, and it just means change in. Okay, when you look at this, it's going to give you, on your formula charts, you'll see a slope of a line as a formula, and it will say y2 minus y1 over x2 minus x1. Okay, this is the change in y, the difference in y, or change in y, over the change in x. That's that formula. This is where you get that, the delta y, delta x. Okay, so we're just relating two variables and how they change in correspondence with each other. Now, before we talk about those things, we do need to jump in and give one or two more definitions here. We need to talk about dependent variable and the independent variable. Okay. We do need to define those because those are very important here. Okay. So your dependent variable is going to be the thing that depends on the other variable. Okay, so your dependent variable is always going to be y. Okay, or okay, and your independent variable is always going to be the x. Okay, this is not what's by equals. This is what you put into the equation. These are your inputs. Okay, this is what changes constantly. All right, and I like to explain this like if you have a question where they're giving you the height of an airplane, and airplane is ascending at a rate of 2,000 feet per minute. Okay, so 2,000 feet per minute, this airplane is going up. So we're going to get this relationship where you're going to get this relationship where you have this airplane. Okay, and it's ascending. It's going up. It's going up at a rate of 2,000 feet per minute for every 1 minute. Okay, so how I describe independent and dependent is, can you ask yourself, because our two variables here are feet and time. Those are the variables. So can you ask yourself, what depends on what? So for tracking the actual altitude, we want to know when he's going to reach 30,000 feet or 20,000 feet or how long it takes him. We're going to ask ourselves, which one depends on what? The altitude, the output, our y value, the total output of the plane at that time, depends on how long it's been traveling, the time here. Okay? So this one, okay, the total height, y, is going to be your dependent, because it depends on whatever you get for this x. It's going to depend on what x is, okay? The total height of the plane will depend on what x, how long they've been traveling. All right, and that's kind of how I look at dependent and independent. You just have to work through it, okay? So, let's take a look at finding, we're going to go back after we talked about independent and dependent and look at rate of change. So remember, rate of change is just a ratio between a change in one variable relative to a corresponding change in the other. So it's a ratio between if x changes, what's the change in y. Okay? All right. So remember, it's delta y, or change in y, over delta x, or change in x. All right? So let's look at finding this from a table. All right? When I look here at this table, there's two ways we're going to go over this. The first one is just by doing a straight change in y over change in x calculation. Okay, I'm going to pick any 2 points. Okay, any 2 points in this table. Let's say I want to pick these two. So these are the points I'm looking at. Okay, those 2 rows. I'm going to look at the y's and see, how did I get from this point to this point? Or what does it change from here to here? How does it change? Well, to get from 11 to 14, you have to add 3. And then I'm going to take a look at the x's and do the same thing. How did I get from 3 to 4? Well, you added 1. Okay, it's just a change of positive 1 from this one to this one. Okay, and then you just go back and say, well, rate of change is delta y over delta x, change in y over change in x, and our change in y is 3, and our change in x is 1. Okay, so that would be our rate of change. You can simplify it to 3 if you want. Okay, they're the same thing. All right, now let's look at the L method. Some students find this easier. You can do it however you want. It's really up to you as long as you can find it. Okay, and what you do is you just take 2 points, any 2 points you want. It does not matter which ones you pick. It does not matter at all. Okay, I'm going to scratch this out so you don't think it's part of this problem. Okay, so I'm going to put in this 2, 8, and then this 5, 17. And the best way, the great thing about this problem is that these numbers don't move. And at the bottom of this chart here, you're going to draw a line that makes it a big capital L. Okay? And then down here, you're going to put the first number in the y, 8 minus 17. And at the bottom, you're going to do the same thing with the x's. They're going to come down and around. So you have 2 minus 5. The tricky part here is if any of these is negative, make sure you take that sign with it. So what's 8 minus 17? Well, that's going to be negative 9. 2 minus 5, negative 3. So you're going to get 9/3. It's the same as saying positive 9 over 3. So you're going to get 9/3 or 3. It's the same thing. Okay? We're going to get the same answer both times. All right, that's the L method. Okay, now let's take a look at this table down here. From this table, what you're going to do is, let's just do a straight calculation. And if you want to try the L method, you certainly can. And make sure you check yourself against this answer over here. Just to make sure it's right and you're doing it all good, okay? Just watch your negatives. But down here, we're going to do a calculation. So what's the change in x? What's the change in y as we go from 8 to 12? How does that change? How do I get from 8 to 12? Well, you have to add what? Okay, it's a positive change. Okay, we're going to add 4. And then over here, this is a situation you're going to run into a lot. Okay, you're going to have a change from 12 to negative 16. Well, this is not a positive change. Okay, it's a negative change. We're going down. We're going down quite a bit. Okay, and so you have to know that that change is going to be negative 28. Okay, negative 28. I have to subtract 28 from 12 to get to this number. But then we just go back to our formula. What's delta y over delta x, or change in y over change in x? Okay, and we're going to get our change in y is 4, so it's 4 over, make sure you take the sign with it, negative 28. And then if you go ahead and reduce the fraction, you're going to get, what's that, 14? Yeah, 2 over 14, or 1/7. Negative 1/7. Check me on that. I'm not quite sure. Okay. Now, let's take a look at a different example. Let's take a look at finding it from a graph. Okay, finding it from a graph. So here we have this arbitrary graph that I made. Okay, and it's some function, and it says, the problem says, given the following graph of function f. So now we've got function f right there. Okay, make that better. Function f. There you go. Okay. It's going to ask you, what is the rate of change? And so we're looking at this function line here, because it is a function. If you do the vertical line test, it only crosses once. Okay. It's actually a linear function. It's a straight line. So we want to find the rate of change here. And we need to find what? We need to find delta y over delta x. Change in y over change in x. So here, if I pick out two distinct points, there's 3 here. Okay, one, there's another distinct point that it's a pretty point is what we call that. It lands right on the intersection of that x and y grid line right there. So it's a really pretty point. We can actually call out that's the point 2, 4. Okay. And then down here, you're going to have the point, this is another pretty point right here. It crosses exactly at 4, 1. Okay, so you can actually label those points. Well, one way you can go about solving this is by just, now that we have 2 points, we just went over how to do it with 2 points, so you're just going to put those 2 points in a table. Okay, x, y, we go, first point is 2, 4, next point is 4, 1. Okay, see that's 1 point, second point. Okay, and then you can either do a straight calculation. What's the difference? How do I change from 4 to 1? You subtract 3. How do you change from 2 to 4? You have to add 2. Okay, so your delta y over delta x, change in y first, it's going to be negative 3 over 2, or negative 3/2. Or you can do the L method, where you come down, you bring the L, you're going to bring these numbers exactly like they look, 4 and then 1, put a subtraction between them, and then bring these numbers down exactly the way they look, 2 and then 4, put a subtraction between them, and then just solve the fraction. 4 minus 1, 3, 2 minus 4, negative 2, which is exactly the same as negative 3/2. Okay, that's one way from a table. But there's another way. Okay. As always, what's the change in y here? How do we get from this point to this point? We have to go what? We have to go down. How many? Down 3. 1, 2, 3. So negative 3. Okay, delta y. So we're going down first. And then how do we get from this point to this point? Well, we went down. Now we have to go right 2. Okay, positive 2. Okay, so it's just rise over run. I hope that sounds similar to something y'all have heard about before, and you still get your negative 3/2. So there's rate of change from a graph. Okay. All right. Now, here's the trickiest part. Okay? It's just tricky because you have to read and think about the situation. All right, so as long as you read and think about it, you'll be fine. But let's take a look at a word problem. Okay? A car is traveling at 62 miles per hour and drives for 6 hours. What is the rate of change for this problem? Okay, it's very cut and dry. It's asking straight up, what's the rate of change? Okay, now, you only have two numbers here, 62 and 6. But this guy is a trap. This number here is a trap. Do not use it. That's a trap. All right, 6 hours has nothing to do with the rate of change in this problem. Okay, it wants to know what that point is after 6 hours. How far has he traveled? And you can find it, and you actually find it using the rate of change. Anytime you see language like this, anytime you see 62 miles per hour, okay, that's 62 miles for every, how many hours? 1 hour in the car. That's a speed or a rate of change. So your rate of change is going to be 62 over 1. Okay, 62 miles for every 1 hour you spend in the car. All right. Anytime you see the words per, for every, you know that's a constant rate of change. It's a linear function, and it's giving you, in words, the rate of change. It's giving you the answer. Now here's the second form you're going to see word problems in right here. It's going to give you a bunch of words, and it's going to bury some coordinate points in there. Okay, so it says, on payday, Susie gets $400. After 4 days, she has $305 left in her bank account. What is the rate of change she could use to represent her bank account? Now there are 2 points hidden in this problem. You only see 3 numbers, but there are 2 points. So I'm going to find these 2 points and put them into a table. All right. There's one obvious one. After 4 days, she has $305. And I should also note here, whenever you see time, days, minutes, seconds, whatever, that is usually going to be X. Usually, and pretty much every example I can think of, time will always be the X value. Okay, that's always going to be your independent. Okay. And so, here's a really obvious point. After 4 days, so there's your X, you have how much money? $305. There's a point. Okay, but here's the, so we've used this, check mark, check mark. We haven't used this guy. Okay, this $400. So it's giving us some arbitrary Y value, $400. But when is that? When is this condition? Well, it's on payday. Okay? And that's the beginning of the situation. So whenever you start something, you don't start at 37, day 37. No. You start at what? We're going to start at day 0. Okay? It's a y-intercept. Okay? That is the point 0, 400. That's where we start. Okay? So when we take these 2 points and we put them into the table, we get usable information that can help us calculate rate of change. 400 minus 305, and then 0 minus 4. Okay? And you're going to go, Mr. Wilkie, this is a negative rate of change. Well, yes. Why? Because our money went down over 4 days. So we're spending money. So we should expect it to be negative. Okay? 400 minus 305, 95 over negative 4. And there is my rate of change. Okay? So, going back to our original notes page, the objective and essential question, what does the rate of change mean? Well, your rate of change is a ratio of how